Hi guys, in this video we're going to work on section 7.3, example 1 and 2. So please open your book to page 544. I believe you guys already BPR'd section 7.3 and then you guys had a lot of things to BPR, right? So let's look at the page 544 first about triangular form for linear system. So, the example 1, example 2 is review. Pretty much example 1 is review of what we've already done in the section 7.1. As I told you, we skipped 7.1 because we already reviewed how to solve a system, right? So we have a vocabulary which is a triangular form. So you may have a question of what does that mean? What is a triangular form for a linear system? So you guys may see this. So x minus 2y plus z equals 7, y minus 2z equal negative 7, z equal 3. So when you guys see that those three, the left part, it's starting with the 3, it goes 2 and 1, so looks like a triangle. That's why they call it as a triangular form. Okay, so this triangular form of the system is an equivalent form from which the solution is easy to read. Yeah, because obviously Z3 is already given to us, so it's easy version of the system that you guys can using the substitution. Alright, so that actually exactly same as example 1. I'm going to show you how to solve example 1, and I'm going to ask you to solve number 1 by yourself. Alright, so this way, obviously your z is already given to us. We would use a substitution method. We have a two method, right? Substitution and elimination. This way, elimination is not going to be working because we don't have full of xyz, xyz, xyz for the three equations. So now, the third equation determines z, which is z equal 3. So I just substitute the value of z into the second equation to determine y. So, you don't have to deal with the first one right now because first one has the three variables. Even if you plug in z into there, it doesn't really help you. So, you have to use your second equation first to find out the y value. Then you can get your x value last. So, you have y minus 2 times 3, that equal negative 7. Now y minus 6 equal negative 7. Now what do we do after? You solve this equation fully by adding 6 each side. Y equal negative 1. Okay, so I got my value z as a 3, x as a negative 1. Then how can I get my x? It's easy. So you go back to the original question. Now what? X minus 2y plus z equals 7. It's time to use this equation. I already know the value. Plug negative 1 for y. And then 3 for z. And x plus 2 plus 3 equals 7. X plus 5 equals 7. Then my x equal 2. Okay? So those three are my answer, and I hope you guys remember how we present our answers. You can either do this, which is x equal 2, y equal negative 1, z equal 3. Or we can use the order triple, which is 2, negative 1, and 3. Please put it in order because always x, y, z order, right? Alright, so I want you guys work number 1 on page 552 by yourself. Alright, so number 1, exercise numbers with the gray background. Okay, that one I don't have to read. Alright, in exercise number 1 and 2, use substitution to solve the system of equations. Both of them are triangular form. My question, x minus 3y plus z equals 0. Now 2y plus 3z equal 1. Now z equal -2. Alright, so as we just practiced, I'm going to plug -2 onto z so that I can get my y value. 3 times -2 equal 1. So 2y minus 6 equal 1. Now I'm going to add 6 each side. And my 2y would be 7. Now what? You divided it by 2. Then your y would be 3.5. Okay? And then what? We're going to plug these numbers into the first one, right? So let me go to the first one. That we have a x minus 3y plus z equals 0. X, I don't know. My y, what was my y? Y was 3.5. Plug 3.5 here. And minus 2 should be 0. X minus 3 times 5 is 15. And 9, 10.5 minus 2 equals 0. X minus 12.5 equals 0. My x would be what? 12.5. So this is my x, this is my z, and this is my y. So how can you represent your answer? Using the, order tripled, which is 12.5, comma, 3.5, comma, -2. Okay? Alright, let's go back to the example 2. So please go back to the page 544. You guys ready? Alright. So before we start in example 2, please look at the page 544 all the way bottom, Gaussian elimination. So transforming a system to triangular form is Gaussian elimination, named after the famous German mathematicians, which is a Gauss. Here are the operations needed to transform a system of linear equations into triangular form. So these steps you have to remember. So page 545. Equivalent systems of linear equations. The following operations produce an equivalent system of linear equations. Number 1. Interchange any two equations of the system. Interchange any two equations. So, that helps you to lining up as the triangular form. And then number 2, multiply or divide one of the equations by any non-zero real number. Okay? So multiply or divided one of the equations. So multiply or divide by with any non-zero number. Okay? And number 3, add a multiple of one equation to any other equation in the system. And then add the multiples. So when you just read a step, it's kind of not clear to you, right? So what is the meaning of multiples? And I'm going to show you. So that one is continuously work of what we've done it to solve a system. So when you solve a system, when we especially work on the elimination, you have to match their coefficient. Do you remember that? They called it as a multiple. So if you times 2 everything to make it into the doubled everything, we call it as a multiple of one equation. So I'm going to show you example 2 on page 545 now. So, remind those 3 steps. Interchange any two equations of the system. Multiply or divide one of the equations by any non-zero real number. Number 3, add a multiple of one equation to any other equation in the system so that we can cancel out the variables. Now, my given question is this: x minus 2y plus z equal 7. 3x minus 5y plus z equal 14. 2x minus 2y minus z equal 3. Let me just double check it not to make any mistake. X minus 2y plus z equals 7. 3x minus 5y plus z equal 14. 2x minus 2y minus z equal 3. Alright, so it looks good. Now what? So you are going to choose what you're going to cancel out. So when we are thinking about the triangular form, the first one should have a x, y, z. Second one has a y, z. Third one should be z, right? So we are going to matching up the order. So when I look at my first and second, I'm going to label as this one as a first equation, second equation, and third equation. I don't need this 3x. How can I cancel 3x? So if you are using this first and second one, if I times 3 and 1, then I can cancel your 3x by thinking about the elimination way, right? So my first step is going to be multiply negative 3. So multiply negative 3 and 2 on 2, okay? And then I'm going to add. Negative 3 times 1 and then add 2. Do you guys understand what I just wrote it down? That's a meaning. Alright, so now I'm going to times negative 1 to everything. That would be negative 3x plus 6y minus 3z equal negative 21. Now I'm going to add with this 3x minus 5y plus z equal 14. You are going to add them up, and then the answers is going to be replaced the second equation. So if you do that, this x cancels out. 6x minus 6y plus minus 5y would be y, and minus 2z equal negative 7. So let me just change my original. So original one, I had a 3x minus 5y plus z equal 14. That become, I'm going to write down right here, that become y minus 2z equal negative 7. And I have x minus 2y plus z equals 7. So I don't change anything for my first one because you need 3 letters. Now, second one, I change it into the y and z. Now, what should I do? I have to leave as a z, right? So my second step for here, my goal is to get rid of my 2x for this, for here. I don't need a 2x, and I don't need a 2y. So you'll just leave as a z alone after. So, how do? We are going to use the first equation again. Why? Because first one has a coefficient as 1, which is easy to multiply, right? So, my second step is this. I'm going to times negative 2 with 1 and add 3. And your answer would be replaced to the third one. So if you times negative 2 for your first equation, you got negative 2x plus 4y minus 2z equals negative 14. Right? You're going to add on to 3, which is 2x. Let me use blue. 2x minus 2y minus z equal 3. So add them up. What's going to happen? The x terms are gone away. And then 4y plus minus 2y become 2y. Minus 3z equal negative 11. So I can replace my third one into 2y minus 3z equal negative 11 right now. But look, this is what we want? No. My goal is to make it into the z equals something directly. So you should be using second and third right now to cancel out your y. So I just write down everything. Here, I don't change anything like first and second one. Now what? Now my step would be this. I'm going to still label as 1, 2, 3. So I'm going to times negative 2 with 2 and add a 3 so that I can cancel out my 2y. That would be negative 2y plus 4y equal 14, right? And you have this one. Now add y goes away. I'm sorry, that's z. Y goes away, and then I got z, which is z would be 3. Alright, there you go. So now I can write down my z would be 3, which is exactly triangular form. So according to this, I can solve the system and I can get my answer. What is my answer, guys? That would be x equal 2, y equal negative 1, and z equal 3. Do you guys understand it? So first, you're going to work for the second one. So you have to cancel out your second one, the first term, which is 3x. And the second step, you're going to get rid of 2x and get rid of 2y by using the first and the second one. Okay? Page 552, number 3. Let me copy the question down. So x minus y plus z equals 0. 2x minus 3z equal negative 1. And negative x minus y plus 2z equal negative 1. Now, I'm going to label my equation as number 1, number 2, number 3 here. First, I'm going to add number 1 and 2. And number 3, I'm going to replace my number 3. Okay? So if you add number 1 and 3, you have x minus y plus z equals 0. Negative x minus y plus 2z equal negative 1. If you add them up, you have negative 2y plus 3z equal negative 1. I'm going to replace for my third one. So if you replace your third one, it will be negative 2y plus 3z equal negative 1. Now what? I'm going to interchange my second and third. So you would have x minus y plus z equals 0. Negative 2y plus 3z equal negative 1. And you have two x minus 3z equal negative 1. Now I'm going to add second and third. I'm going to replace into my third one. Negative 2y plus 3z equal negative 1. 2x minus 3z equal negative 1. If you add them up, you have 2x minus 2y equal negative 2. I'm going to replace my third one with this. So x minus y plus z equals 0. Negative 2y plus 3z equal -1. And you have 2x minus 2y equal -2. Now I'm going to times -2 onto my first one. Add onto 3, then I would have -2x plus 2y minus 2z equal 0. 2x minus 2y equal -2. If you add them up, you can cancel x and y. You have -2z equal -2. So you're going to switch up your third one into this, which is -2z equal -2, but you can do divided by 2 each side, right? You can divide by any non-zero number, so that will be -2. So I can copy my first one, samely here, and my second, and my third. If I divide by -2, then your z would be +1. That's my triangular form. Now what? I need to get my y and z. Y and x. So I can replace my 1 into the -2y plus 3 is equal -1. Then you get that? You get that? And you have -2y equal -4 divided by -2, then your y would be 2. So you got y equal 2, z equal 1. Now how can I get my x? Plug everything back. X minus 2 plus 1 equal 0. X minus 1 equals 0. Then my x would be 1. So you can write down your answer in ordered triple, which is 1, 2, 1. That's the answer. Alright, I hope this video helps you understand. We're going to see the next video. Bye.